Any question? So now, after we have the cosine of a sum identity, then how can we find the identity for the cosine of a difference? How do we make use of the identity of a sum to get identity of a difference? Say again? Use the opposite, right? So you may rewrite this minus beta as the plus the negative beta, right? So alpha minus beta same as the alpha minus the opposite of beta. So now this expression is in the form of the cosine of a sum of two variables. Then we can use the cosine of a sum identity to get the expression for this cosine of the alpha minus beta. So I have the cosine of alpha, cosine of negative beta minus sine alpha and sine of the negative beta. But we know, okay, cosine is even function, so cosine of negative beta is equal to cosine beta. And sometimes we may just go without this parenthesis. So cosine alpha, cosine beta. And sine is odd function, so sine of negative beta is equal to sine beta. So now negative, negative, you have the positive. So now we get identity of cosine of a difference. So cosine of alpha minus beta equal to cosine of alpha times cosine beta and plus sine alpha times sine beta. And this is called the cosine of a difference. Okay. Now let's look at the page 529, example 2. Try this part. And we need to find the exact value of the cosine of the 75 degrees using this cosine of a difference. We know we can use the cosine of a sum to find the exact value of this guy. But here we need to use the cosine of a difference. Now tell me which two angles should I use so that this 75 degrees is equal to the difference of those two angles. Say again. (75 can be written as the something minus something, which is the first 120. You see, and then second 45. Yeah, it's okay. Let's see, let's double check. Okay. Yeah, so 120 degrees minus the 45 degrees, right, is equal to 75 degrees. Okay. And you can also rewrite this as the 135 degrees minus 60 degrees. So the way is not unique, right? You have the many different ways to rewrite the 75 degrees as the difference of the two angles for which you know the exact value of the sine and cosine. So now let's use the second. So you have the cosine of the 75 degrees. This guy is equal to cosine of the 135 degrees minus 60 degrees. Then this is equal to cosine of 135 degrees times cosine 60 degrees and plus sine 135 degrees times sine 60 degrees. Now, what is the reference angle of the 135 degrees? 45, right? The reference angle for the angle 135 degrees is 45. And what is the sign of the cosine in this quotient 2? Positive or negative? Negative, right? In the quotient 2, x coordinate is negative. So you have the negative cosine of 45 degrees. And then, let me copy this. Now, what is the sign of the 135 degrees? Positive or negative? Positive, right? And we know the reference angle is still the 45 degrees. So this guy is equal to sine of the 45 degrees. And then let's plug in the values for this 4 trigonometric function values. So negative root of 2 over 2 times 1/2 root of 2 over 2 times root of 3 over 2, and then it simplifies. So you get it. Root of 2 times root of 3, root of 6, and then root of 2 times 1, root of 2, and then over 4. Then done. And for those 6 trigonometric functions, we can group them, okay, like this: sine and cosine, tangent and cotangent, and then secant and cosecant. So in each group, they are called the cofunctions. So sine is a cofunction of the cosine, tangent is a cofunction of the cotangent, and secant is a cofunction of the cosecant, and vice versa. So now, let's try to derive the identity for cofunctions. And let's begin with the cosine of the half pi minus beta, and use the cosine of a difference. We know this is equal to cosine of half pi times cosine beta plus the sine half pi times sine beta. Okay, so what is cosine half pi? 0, right? Cosine half pi is 0, so this part just gone. And sine half pi is equal to 1, so totally this is equal to sine beta. Now we net beta equal to half pi minus another angle u. And let's see, we have the sine beta equal to sine of the half pi minus u, right? And then on the left side, we just replace this beta by half pi minus u. We get cosine of half pi minus this beta. Beta is equal to half pi minus u. And then we simplify, we get cosine u, right?